All right, we're back. We are on page 5 of notes 4 of Calc AB. Differentiability and continuity, giant ideas, just definitions, use a lot of limits. Last time I had a ton of technical difficulties at the end. I couldn't really figure out what was going on. I used the tried and true technique of turning it off and back on again, and we're good to go. I mean, I only had to quit the app, but I also had to learn how to quit the app because this thing's a little bit different than the I have like a standard iPad before, and this is an iPad Pro. It's amazing. I definitely kind of recommend it if you're in the market for that kind of thing. Certainly if you're a teacher watching these and you're going to try to make your own videos, like, oh my God, go for it. Also, Apple Pencil. It's got to be the Apple Pencil 2 though. For the month before this, I was using this Apple Pencil 1, and it turns out it's not compatible. So then I had to buy this. You were looking at like $230 worth of styluses right here. But I have no regrets. No regrets about buying this. I wouldn't have survived the last month without it. So it's great. Did its job. I was going to buy the iPad Pro anyway, and it wasn't going to be compatible no matter what. So maybe I'll sell that at some point. Who knows? This one's very cool. Yeah, so that's the end of the product review for now. These are the answers to the last one in case, I don't know, whatever you're doing, if you wanted to screenshot this and copy it down at some point or whatever. And then let's keep going. So let f be the function defined below. So f of x is x cubed minus 27 over x minus 3, only when x is not 3. And then f of x is 18, for whatever reason, when x is equal to 3. And we have to decide which of the following are true. So first one, the function has a limit. So if the function doesn't have a limit, then the function can't be continuous. If the function isn't continuous, then the function isn't differentiable. So let's kind of hope that it doesn't have a limit, but I'm pretty sure it does have a limit. I can think of 2 ways to evaluate this limit. So, well, I can think of more ways. I can think of 2 ways that we know right this minute. So the first one, I'm going to try to find the limit as x approaches 3 of f of x. So remember, the weird thing is use the definition that doesn't involve 3, right? So because limits, we don't want to know the value of the function. We don't really care. We just want to know the limit as you approach it. So we're going to use the top definition. So it's the limit as x approaches 3 of x cubed minus 27 over x minus 3. I guess I can think of a third way that we can do it right now. So if you remember how to factor this, then, well, first of all, we try to plug in, right? When you try to plug in, you get 0 over 0. And do that in like a different color here. You get 0 over 0. So now you go to work, right? So if you remember how to factor a difference of cubes, good for you. You'll get this. So that would be the limit as x approaches 3. All right, so it's you can use the acronym SOAP. It's like literally how I remember it. So it's going to be the same sign, the opposite sign, and then always a plus. So this will be, some of my students actually taught me that. And I'm not one of those teachers who's like, oh, you need to learn and understand. Like, don't use useful things that help you to always remember. No, use them if they help. So it's going to be the same sign. It's going to be the opposite sign. So it's going to be plus, and then you just multiply them. So 3x, and then it's always a plus, and it'll be the square over x minus 3. We can cancel the x minus 3's. We should do another step here. So I'm gonna magic this over a little bit so that I can pretend that I was doing it in the right spot. So we should do another step because really this thing is still indeterminate the way it's written. X squared plus 3x plus 9. Then you plug in, you get 9 plus 9 plus 9, so you get 27. Okay, that's one option. So that's if you remember how to factor a difference of cubes. Some or difference that will help you with, by the way. If you don't remember, but you get 0 over 0, it means that x minus 3 is a 0 of, or is a factor rather of the numerator. So what you could do is you can actually do long division. Well, I'm going to do synthetic division. So it'll be 1 because it's 1x cubed, 0x squared, 0x's minus 27. Okay, drop down, multiply, drop down, multiply, drop down, multiply, drop down. Well, add down. Drop down means add down every time I said it. Well, except the first one. So drop down, multiply, add down. multiply, add down, multiply, add down, whatever. Like it worked, right? So this tells us that the original thing, so x cubed minus 27 is equal to x minus 3, and then it's x squared plus 3x plus 9, and we're good, right? So that's if we had not known how to do that, and not known how to factor, which honestly for like 27 years, I could never remember how to factor that. And then my students told me that, and I was like, ooh, awesome. But I always used to do the synthetic division thing. So like no harm, no foul. The other way I can think to do this is that this limit here, right? This limit, now I really like this highlighter color. That limit is actually the limit definition of a derivative. So the limit as x approaches 3 of x cubed minus 27 over x minus 3 is equal to f prime of 3 for f of x equals x cubed. So look at that. It's f of x minus f of a over x minus a. The limit as x approaches a. Definition of the derivative. So if we could find f prime, it would be 3x squared. F prime of 3 is 27. We're going to get 27 no matter how we do it because that's the limit. But I wanted you to know that there's like a lot of ways that we could do it. So we've gotten 27 there. So the limit, f of x has a limit. This is true. Okay, a lot of work for that. And we only need to do one of them. I did 3 of them, whatever. F of x is continuous. So for f of x to be continuous, we need the limit to exist. So the limit as x approaches 3 of f of x we just found was 27. We need the value of the function to exist, f of 3. By the definition, f of 3 is, where's a good highlighter color? F of 3 is 18. So it's 18. But as soon as we get that, we know. So let's say since the limit as x approaches 3 of f of x does not equal f of 3, f of x is not continuous at x equals 3. So knowing the definitions is extremely helpful. So this is false. And then f of x is differentiable at 3? No way, right? We just said that the function is not continuous at 3. So this is false. And since f of x is not continuous at x equals 3, f of x is not differentiable. I should have used different colors all the way through, you know, to help you to distinguish the work for various parts, but didn't. At x equals 3. It's one of those things every once in a while my brain is like, you should have done a better job. But that's all right. All right, next problem. Find the value of k that makes the function f of x equals, it's another piecewise function. It's like basically the same problem. Find the value that makes it continuous. All right, so what needs to be true? We need the limit to exist, the function to exist, the limit to equal the value of the function. So the real trick here is finding the limit. So we need the limit as x approaches 11 of f of x is going to be the same as the limit as x approaches 11 of x squared minus 121 over x minus 11. So at this point, you should start thinking to yourself, can we do the derivative thing? Like, is that going to keep working? It will work frequently, right? So look at this function. If you say f of x is x squared, then f of 11 is 121. So that difference quotient is f of x minus f of 11 over x minus 11. If we take the limit as x approaches 11, we are in fact finding the derivative of x squared over, no, we're just finding the derivative of x squared at x equals 11. So derivative of x squared is 2x, so we're going to get 22. That's going to be the answer. So I would recommend that you start thinking that way as often as you can. I'm going to do this algebraically though. Well, I'll do it both ways. I mean, I just did it that way, but I'm going to show the work. Factor, because just a ton of limits that you look at are actually the derivative. I would say almost most, once you really get into calculus, most limits that you look at are actually the derivative. So we get 22, as expected. Or f of x is x squared, f prime of x is is 2x, f prime of 11 is 22. Like, it's an alternative way of doing it. This should have been a 2. It does not look that great. Okay, so we found the limit. So we need f of 11, which is equal to k, to equal 22. Therefore, k equals 22. So as long as, who makes their 2's differently? So as long as k is equal to 22, this function is going to be continuous. So I don't feel like that's the best explanation. Maybe I'll like move this down. So maybe I'll say like, we need, oh, good. We need the limit, we need f of 11 to equal the limit as x approaches 11 of f of x. Therefore, and then I'm going to move it back. Therefore, f of 11, which is equal to k, will equal 22. It's still not great, but I think it's better. And I'm always looking to try to like make my answers better, so that they're just more readable and they just look more presentable. And you take pride in your work, people. All right, so we did a bunch of things here. Felt very similar all the way through. A lot of techniques for finding limits. Start trying to think of limits as, could they potentially be the derivative? If you can see that, that's like one of those calculus superpowers that other people do not necessarily have. Gives you a nice little advantage. So I'll be back in the next video to finish off these notes, I think. So I will see you there.